All right, everyone, welcome back to part 2 of the drilling lecture, drilling and tapping. So this is part 2. We kind of left off here talking about the Jacobs chuck and the keyed portion of it. The next phase we're going to go into, occasionally as a fabricator, especially if you're working on a high-end assembly production, you're going to be discussing reamers. Now, reamers are basically, let's take a look at a reamer real quick. They're a precision product to be able to get a nice fine precision down to the within that 2,000ths tolerance, right? So if you've got a shaft going through something, you may have to fabricate the piece, but you need that bolt hole pattern to be able to fit within that shaft or that bearing to be right down to a precision fit within like a 2,000 or maybe a 20,000 press fit or something like that. So a general typical application of finishing or guidelines for a reamer instead of application. Sorry, we already discussed that. But you have a smoother finished surface. The parts include the cutting tip, flute, shank. It looks like there's no tip to it. It's just a flat end piece with a lot of flutes to it. Now you can see these are expansion reamers. Sometimes these come in handy in really deep holes because the edge is cutting, but sometimes they can wear out and then the back section stays put. Okay, so if you've got a lot of chips that you're removing, then you go from there. Most of what we're going to deal with are these solid piece reamers because they are fairly expensive. Again, all of these edges have a cutting edge. Let's discuss them here. So there's multiple cutting edges as we go. And then your entrance into this piece. So we may have to countersink that hole just a little bit before we get to help this reamer get started. And it has a slight chamfer here on the end. So when we start talking about a reamer diameter, say we want to finish to a 1/2 inch hole. Okay, and it's got to be a finished 1/2 inch. So we get a 1/2 inch reamer. What do we want to drill to? Typically when we're drilling, we want to be 1/16 under, anywhere between 40 to 60 thou. General rule of application would typically be 1/16, especially like in tubing or light gauge material. If you're looking at like Inconel or stainless, again, that's usually what machinists are doing. So we don't typically deal with that. Then we'd look at like maybe a 30 thou difference. But for most of the time when we're on a drill press, I want to say a 1/16 to kind of eliminate any of that whole oblong or ovaling and going from there. Plenty of lubrication. So if we had that 1/2 inch hole, I'd want to drill a 7/16 and then I could ream that last 1/16 out. Okay. Let's move down. Basically a couple different versions. Here's a Morse taper, which is a tapered chuck, which most of you have dealt with our mill a little bit, our handheld mill, and then here's a straight chuck reamer as well. Okay. These are tapered reamers for a tapered hole. Occasionally I don't see us really having to use that. Again, this is from the machining book, but a lot of machinists and so forth will have to do that. Okay, so the countersinks and counterbores is kind of our next section. Okay, it talks a little bit about it in the other handouts as well, but this one does a much better job. There's multiple types of countersinks and counterbores. Typically, let's look at this. Here's a zero flute countersink, right, with a pilot edge up front, keeping it centered, but there's no flutes. The edge is leading and it catches it and chamfers it there. Multiple diameters and dimensions, but each bit can also cover multiple diameters and dimensions as well. Here's a couple different versions. Here's a single flute countersink. You got to be careful. Sometimes these can bite in and leave a little bit of an edge as you're done. 3 and a 4 flute as well. Okay. All right, 6 flute countersinks. A lot of times these multi-position countersinks are usually used for softer material because it doesn't dig in or you don't want to put as much pressure on it. All right, so here's our difference. Let's talk about a counterbore hole. So counterbore hole means exactly that. It's straight down. It's got a flat bottom. So this bolt head is going to suck up nice and tight to that edge. And you want to counterbore deep enough so that this bolt hole is no longer flush. It's below flush at this point. A spot-faced hole is basically just the same thing, but only deep enough for the washer. Okay. All right. So let's come back and talk about a couple things before we jump into the tool holding section. So at this point, I'm going to kind of stop discussing too many more other options on countersinks and drill bits. Now we're looking a little bit at, I want you to look through this handout talking about basic properties. Think about high heat, high friction, your feed rates and everything else definitely are affected. In here it talks a little bit about high carbon steels and high speed steels. So we've got an 1841, tungsten's used, 4% chromium, and so forth. Okay. Cemented carbides, again, carbides typically you don't want to get hot because they're held onto a high-speed steel with a lower, like a brazing material, and most brazing material can start to come apart before the melting temp. So you cannot withstand it. You have to keep it under a certain amount of degree, or certain degrees and a certain temperature. Okay. They do last well, but if you're using cemented carbides, you need to make sure drilling, particularly, that you're using a lot of lube and fluid to keep it cool. Okay. And then they go into quite a bit more details in here. Again, feel free. I've not yet seen if any of these videos still exist, but I bet they do. But feel free to look through that a little bit just so you have kind of a base understanding. Okay. We're going to go back to that PowerPoint now. The other part that I really wanted to talk about here was just to give you an idea what some tools are like. So we've talked about tapers and Morse bits, right? So we talk a little bit about how do we get this thing out once it's tight. We actually use a drift. So that drift goes in. You put that drift in here. I think it shows a picture of it here in a minute. No, I don't see one. Oh, here it is. So you put that drift in and then you nail that in with the hammer, and basically it's a wedge that forces that out. Okay. Alright, and we've got our different types of chucks. Naturally Jacobs type drill chuck, a keyless drill chuck, and then there's a micro or a pin vise chuck for a small drill set. Okay. The next part that I really wanted to focus on was work holding. A lot of times we use clamps and we can use what we can, but what do you do if you've got some small pieces you need to assemble and work from there? Number one, try to use a vise if you can. If you notice this has an edge on it, remember we do have parallels inside of there. You can put a set of parallels in there if you're working on a round object to set down on top of this, your guides, so to say, through your vise. Okay. Make sure it's seated nice and flat. Here's a good example of a couple different versions of doing this. Alright. So if you're going to drill through this piece, then we might have a little bit of an issue here. We need to bring it off of that bigger, heavier parallel versus these two small parallels. Okay. But typically, a lot of times we've got a vise or we've got like what we call a V-block. So this V-block helps us keep centered. We can find top dead center, and then we can use a centering head to be able to come directly across from this in any different direction that we need to. Okay. Here's a couple different versions. Again, they all have slots to be able to hold in there, to be able to have that round piece stay there and drill down into it or through that piece. But what about a flat piece, a small flat piece that we can't seem to fit a clamp on or anything else? That's where a typical angle block will come in really handy, right? Here's a good example of that. We can use some bolt through holes and some tool holding devices here on this drill press to be able to get it fairly close. Again, you need to level out your drill press, make sure it's parallel to this section first, or change it to the angle that you want, preferably. Okay, multiple versions. Naturally, you know, this step wedge is supposed to help you get taller pieces. Put this up here, it anchors down, kind of ratchets in, and we can go from there. Okay, so that's the end of the drill bit section that I really wanted to talk about and focus on. I still have about 4 or 5 minutes. I want to discuss a few things on the taps and the drills. Okay, so hand taps and proper threading techniques. Most of you have done this at this point. You can read through this and feel comfortable too. The main thing I want you to think about is think of taper, plug, or a bottom. There's multiple types, and you can see the tapers ground down. The bottoming one is actually the one that you take down to the bottom of like a non-through hole, so to say. Okay, so know those differences, and then naturally the dies are on the outside, and we're going to spend a minute lubricate. This is really important. Okay, very important to always have lubricate. And then it talks about taking your time, break the chips up, back out a turn or two just to kind of get things loose, and then go back in. You want to try to make sure to use a slow approach when fitting or when threading. Okay, so feel free to read through this handout as well. This kind of talks a little bit about them. Basically, they're a lot of the same materials as drill types, and so forth. The other thing that I really want to discuss is sometimes we talk about from welders like drilling and tapping. We know how to tap and get there. We can tap off a lathe. We can tap off the drill press just to keep them square. We can put them in neutral and just start to hand tap them if we need to. Okay. But one thing I want to talk about, say I want a 1/4x20 hole. Then using this Starrett chart, what we have to find, number one, is we have to find the tap size, and then it'll give us our fraction or our drill size. Okay. And sometimes it's, it might give us a decimal equivalent or something similar. Usually if we need to tap or drill or tap or die something, we know what this is. So first of all, let's talk about a normal bolt hole pattern. These are your normal machine screw type setups. 1, 2, 3, 4. A number 10, 24. I'd use a drill size number 25. And as we get over here, there's, after you get through the single numbers, there's fractional, but there's also lettered drill sizes as well. So say I want to do a 1/4x20, I want to thread a 1/4x20 hole, then I need to drill it out with a number 7 size drill bit before I start drilling it in. Vice versa, let's come over the 1/2 inch by 30, or by 13 threads per inch. Naturally, it's the pitch from point to point on my thread, but I want to use a 27/64 drill bit to drill that hole out. And as you can tell, that's a 1/2 inch hole. That's our major diameter of our 1/2 inch, and then our minor as well. And we kind of break into that a little bit. We don't discuss it too much on threading. Okay, let's come down here real quick. Here's our metric conversion. The other last thing I wanted to catch before the end of this video and letting you go is talking about pipe thread sizes. So a nominal pipe size is what we're dealing with. So 2 inch is 2 inch, and so forth. So if we want to thread a 2 inch pipe, then we're going to have 11.5 threads per inch. Okay. The drill we need to do is a 2 and 7/32, and these are usually a pretty aggressive piece. It's going to take a lot more lube and going a lot slower. Okay, well, I'm about out of time for this second one, so we've covered the basics around it. Feel free to read through that. I'm going to have a test out there. You can also spend some time researching, but that covers the basics, the highlights that I wanted to point out, particularly when dealing with drills, twist drills, and drill bits, as well as tapping and dyeing. And let's not forget the counterbore, countersink, particularly. Most of us have heard those in our conversations to this point. Thank you, have a nice day, and we will talk to you later.